Okay, we finally reached this part where we'll implement assassination on our enemy AI from behind. Today's video will most likely be the last one in this series for now, and we'll use motion warping to perform the assassination with a ready-made animation you can download for free. It'll be an easy and creative video as usual, so let's begin. First, go to the AI controller and create two Boolean variables. Name the first can do assassination. What we'll do with it is determine when we can perform the assassination and when we can't. The idea is simple. When the AI is not chasing us, we can do an assassination. Otherwise, we can't. Also, an assassination can only be performed when we are behind the enemy. So wire this variable into the back check logic we created earlier. The second Boolean we'll name stop all. Its purpose is to stop the AI from acting while we assassinate it. I know there are better ways to do this, but from my experience, it's safer to stop it manually. Otherwise, very strange bugs will appear later. Trust me. So put that variable into event tick. When the condition is true, hide the warning widget and reduce the alert level to 0. Then also plug it into the patrol force movement logic so the AI's movement is completely stopped. I'll find the node. Yes, here. We stop the AI movement entirely to avoid issues later. That's all we'll do in the AI controller for now. Next, in the AI character, create a new Boolean variable called isDead. For now, we'll just keep it like that. Now go to the player character where we'll build our assassination logic. The first thing we need to do before executing the assassination is find the nearest enemy AI to the player and check whether an assassination is possible on that target using the condition we discussed. To do that, we create two custom events, assassination enemy and find the close enemy. Then create three variables. The first will be a map that pairs a float with a reference to an AI character. The second will be a reference variable to an AI character called the close enemy. And the third will be a Boolean called is assassinating. Go to find the close enemy and start building the logic. First, get all AI character actors in the world with get all actors of class, then loop over them with a for each loop. For each one, check its distance from the player and store those distances in our map. When the loop finishes, find the smallest distance using getMin of float array or getKey, use min, then find which actor owns that distance using find. That will be the nearest character. After that, call the assassination enemy event. Don't forget to clear the enemy data at the start. Now implement assassination enemy. First use do once and ensure we aren't already performing an assassination on another AI. Then check two things. First, that the enemy we want to assassinate isn't already dead. And second, that it is in a state that allows assassination. Next, determine the maximum distance from which we can assassinate the AI. If we are outside this distance, we cannot assassinate. We do this simply by checking that the distance between the nearest enemy and the player is less than or equal to a variable zone assassination. Set it to 200 for now. You can change it later. If the previous checks fail, reset the do once. If all conditions pass, set is assassinating to true. Now play the assassination animation. As I said at the start, we'll use motion warping. It's a system that always aligns the target to a specified point, regardless of orientation. To use it, first enable the motion warping plugin from the plugins list and restart the engine. Then add a motion warping component to the player. That's important. Next, import the assassination animations. I'll leave the download link in the description and on my Discord. We have the assassination animation and a strangling animation. I think they're good enough to be the basis for our system. We only need the assassination animation right now, but we'll create an animation montage that contains both since we'll need both later. Inside the assassination animation, add a new notify state of type motion warping and decide when you want the player to be warped toward the target. We want that to happen at the start. I'll tweak it a little later. Yes, that looks fine. The last step is to add a warp target name. I'll name it Kill and leave the rest at default. That's all we'll do for now. It's very simple. Now what we need to do next is stitch the assassination animation and the strangling animation together, so they play like one continuous scene when triggered. To do that, we must precisely place the start point of the assassination animation behind the AI. So we go to the AI character and add a new skeletal mesh component. Put the player mesh into it and adjust its position and rotation, making sure it's set to hidden in game and no collision. We make it play the assassination animation. One important note, enable root motion on the assassination animation. That's essential, so double check it's on. Then for now, pause the player's normal playback and make the AI character play the strangling animation only and stop its movement too. Okay, I accidentally swapped the animation names. I'll rename them quickly. And then we only need to move the player mesh to match the strangling animation. As you can see, its position looks good. Now restore the AI mesh to normal and hide the player mesh again. Next, we return to the player character. From the player mesh, we will call play montage to play the assassination montage. Then using the motion warping component, call add or update warp target. Add a warp target. Rotation comes from the close enemy via get actor rotation, and whose location uses the player mesh we just created. After that, play the strangling animation on the AI. Remove its collision and add a delay equal to the AI strangling animation time minus 2 seconds. After that delay, we clear the assassination flag and reset the do once. The final step is enabling ragdoll for the AI at the end of the assassination. So we go back to the AI character and create a new event called ragdoll AI. First, we call stop all, the variable and event we created earlier, and disable AI perception. then unpossess the AI controller. This ensures the AI stops working entirely after the kill. Then we adjust collision responses for the capsule component and the mesh regarding pawn collision and camera, because we don't want any collisions during the animation. And set is dead to true. After that, we use a small delay and call a custom event. First, we lift the character slightly upward to avoid ground penetration when ragdolling. Then change the mesh collision to physics body. And set camera response to ignore. Do the same for the capsule component. Then set enable collision to query and physics. And finally, enable simulate physics. That's it. Put this event where needed. The duration will be the animation time minus 0.2 seconds. To test, pick any input key you like to trigger the assassination and bind it to the find the close enemy event. Let's try it now. Good. It works, but the animation origin needs some tweaking, so adjust it. From prior testing, I know the best coordinate offset is 53, so set it to that and try again. Nice. The animation now lines up very well, and the ragdoll adds a satisfying feel that works great for any game. Everything's working nicely. One last thing. Add an assassination widget. So, whenever the player is in assassination range, a little assassination icon appears with a small animation. First, create a widget and put the full-size targeting image inside it. In the animation panel below the widget, create a new animation, add the target image, then click the plus and add a transform track. Expand it and animate rotation slightly so it loops every 2 seconds. An event construct, you'll see a new variable named new animation from that run play animation set. Num loops to 0. That's it. Now in the AI character, add a widget component and assign the UI target widget. Use the same settings as the UI warning widget we made earlier. Just tweak the size a bit. Add the same look at camera rotation logic so it always faces the camera. Copy the logic and reference the new widget. As a final step, don't forget to add a tag named target to the AI. Then go to the AI controller and create a reference to it the same way we did before. With vision collapsed. Create a custom event called widget target visibility to control when the widget appears and when it doesn't. The logic is simple. Hide the widget when the AI is chasing the player. When the AI is not chasing, and stop all is not true, and the player can perform an assassination, then set the widget visible. Hook this event to event tick and test. It shows up normally, although it overlaps the warning widget. It also didn't hide when the AI died. I think I know why. We must check its visibility before the global stop condition. Move the visibility call before the stop all check, and it should behave correctly. All right, I remember there was another bug that showed up earlier. Let's check it. Ah, yes, there it is. It's easy. Just put an isValid note here and the issue will be fixed. Before we start testing, let's tweak the target widget so it doesn't overlap the warning widget. We'll make it smaller, move the warning widget away from it, and slightly adjust its size as well. Now let's do a final test. When I get close while the AI is unaware and I'm within assassination range, the assassination widget appears exactly as we want. Excellent. Even the assassination animation plays without problems. Before we finish, let's test everything we built across this series. I'll add more grass in several hiding spots, spawn several enemy AIs in the world, and create patrol paths for them. The scene looks beautiful from here. It gives you a real sense of accomplishment for what we've built so far. I'll also take this chance to talk about what's next in the series. For now, I've decided this will be the final video in this series, since we've achieved our goal of building a stealth and enemy attack system. That doesn't mean it's the end. I'm thinking of continuing this work in a future, more advanced series that will include some of your ideas from the comments. The big plans include making the AI more aware of its surroundings, such as detecting allied enemies we knock out and alerting their teammates, building camera-based surveillance systems, and much more. But as I said, for now we'll stop at what we've made. Thanks for following along up to this video. See you in other upcoming series soon.